Check two, check two, check two.
Welcome back to your favorite stats class of all time. I am your humble host, Chad Bemis. Let's delve into some graphs today, shall we? Module 1.1, Picturing Distributions with Graphs. We're going to look at histograms, which are like bar charts, and stemplot as well. All right, quantitative data. Do we remember what quantitative data means? Data with numbers that mean something that can be compared to one another. They can take on different values, and in creating the distribution of these values, we must first examine some vocabulary here. A class is a subgroup of equal width in which data falls. So what this is going to do, it's going to allow us to take our data, put it into classes. It's also going to make it easier to read. The frequency is a count, the number of data which fall into a given class, just like the count that you remember from Sesame Street. 1, 2, 3, doing the betty bet. The lower class limit is the smallest value that can belong in a given class. The upper class limit is the largest value that can belong in a given class. So what we're going to be doing is we're going to be creating what are called frequency tables or frequency distributions. And then with these frequency tables and distributions, we're going to create either Stemplots or histograms, which are like bar charts. So we can do this with categorical data. We can also do this with quantitative data. With categorical data, you're not going to see numbers on the horizontal axis. You're going to be seeing the categories. So the vertical axis will represent frequencies or counts, and the horizontal axis will be the categories themselves. So for quantitative data, you're going to decide on the number of classes based on how many data points that you see. It's good to try to keep the number of classes low if possible, because if you have a large number of classes, then you're going to have barely any data points fitting in each class. And on the other side, if you have too few, then it's, you're just not going to get a good graph of the data. So we say about 5 to 10, depending on how much data you have. If you have a small number of values like 20, 25, then go toward the lower end. If you have a larger number of values, say 50, 75, 100, then maybe 10 would be appropriate. We're also going to choose an appropriate class width. The class width also corresponds with the width of the bar itself when you're drawing the bar charts. So this is the width right here. And when the lowest value from the highest value determines the class width. So if the lowest value is 100 and the highest value is 200, that's like the lower class limit of one class to the lower class limit of the next class. Of course, if I was to subtract the two values, then the width itself would be 100. So that's what we're talking about when we say the width. We're also going to divide, in order to determine these classes, what we're going to do is we're going to take the minimum value, also known as the lowest. We're also going to take the maximum value in the list, which is the highest, and subtract them. And then we divide by the number of classes. So I'm going to show you an example of this and then round to a sensible width. And then find the class limits, determine the frequency of each class. So remember, the frequency is the count, how many, right? All right, so here's a categorical example. Neck pain associated with carrying a school bag. So we're talking about schoolgirls. Don't know what grade, 6th grade, 7th grade, right? And these were 585 responses. The question is, do you have neck pain? Never, almost never, sometimes, often, always, in total. So you can see that 179 of the girls responded never to the question. 159 responded almost never, and so on and so forth, for a total of 585 responses. So then if we were to look at the bar chart for this, you can see that we go from never all the way up to always. The height of the bar is represented by the count or the frequency, right? So even though 150 is the highest, you can tell that the height of that bar is somewhere around 200, maybe 180. And if we go back, yep, there's the 180 right there. So the height of this bar 180, the height of that bar 160. So there's the 160 right there. So again, this sort of gives you an idea of, or at least a small snapshot of what the data looks like. Sometimes the data will be, there will be enough data points so that it will be what we say normally distributed. And the usual normal distribution looks a little something like that, like bell-shaped. So in this case, it's not really bell-shaped. It's skewed towards this side over here. And we can talk about distributions of data. We will talk about that. Also, this is basically the same bar chart, but done alphabetically. Here's another example. At a glance, can we tell how many data points there are? We have 1, 2, 3, 4, 5, 6 down, and we have 1, 2, 3, 4, 5, 6 over. So how many data points do we have here? 6 times 6 is 36 data points. So this is an example of where we could take this. We could figure out what the highest value is. We could figure out what the lowest value is. And then from that, we can determine the frequency distribution. So we can make our own frequency distribution. So first of all, what is the maximum value of this entire list? Take a quick look, see if you can figure out what the maximum value is. Is it 203? Let's double check that that's correct. Looks like it is. Now look to see what the smallest value is in the list. Is it 25? So then we would take the maximum value and subtract the smallest value. And that would give you a range, right? That would give you a range. And that's, was that 178? We can double check that with the calculator. So that's our range of values. So what they've done here is you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes. And what this interval means, whoops. What this interval means here is that it includes 20 but does not include 40. So technically we're talking about 20 to 39. So this is serum CK levels in men. So these serum levels, basically 20 to 39, we had one man that fit that description. So that was the 25 that we had referred to earlier. That was the one man that fit that description. So as I have this printed out, perhaps I could just cross that off so I know I've used it. Then if I'm looking at the 40 to 60 category, let's see if we can figure out where the 4 men came from there. Any number that's between 40 and 60, not including 40, right? So that doesn't, excuse me, not including 60, but definitely including 40. So there's 1, 2, 3, 4. So those are the 4 that counted for that category. Okay, oops, wrong way. So, and then on down the line. So there should be a total of 36 when you get all of your frequencies. And you can see that the width of each of these classes is exactly the same. If I was to take the lower class limit here, 40, and subtract the lower class limit of the previous class, 20, I would get 20. So the class width is 20. The class midpoint is unique for each class, but you can see that it hits 30 here, 50, 70, and so on. So those are the class midpoints. And those midpoints and the width will determine what the histogram will look like when we draw the picture. So you can see the width is 20, that's 40 right there. There's the one person that fit that category. There's the 4 people that fit that category. So this, you can see this histogram, that's a little bit closer to the normal distribution, the normal bell curve. And this is sort of what we would expect. So the more people that we survey, 50, 100, up to 1,000 and so on, the more we would expect these levels to fit into this bell curve, so to speak. Now the shape features of this distribution, we call this the left tail. Remember I had drawn that bell curve, so this is the left tail of the curve. This is the right tail of the curve. And then the mode would be where it's highest right there. So notice that it's bimodal. We have 2 modes here. Now those modes, as you remember, correspond to the 80 to 100 and 100 to 20 serum levels, CK concentration serum levels. Another example here would be percentiles on the NCLEX nurses exam. Percentiles mean that, let's say the 63rd percentile means that of all the data points, in other words, all of the nurses that took that exam, you scored higher than the lowest, you scored higher than 63% of the test takers, and you scored lower than 37% of the test takers. That's what the 63rd percentile means. Anyway, so these are percentiles for, let's see how many scores, 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that must be 30 test takers, right? So out of the 30 test takers, these are the percentiles. So one thing that you can try to do is create a distribution table of the percentiles using the 5 classes and display your results in a frequency histogram. We're not going to do it on this video, but download this PowerPoint from the appropriate block and try to do that yourself. Okay, we can talk about that in class as well. Stemplots. One of the downsides of a distribution table and histogram is that while it gives a good visual distribution, the original data is unrecoverable. As you can see from the table or the histogram here, it doesn't really tell us what the data points are. It just tells us the general shape of the data. But one nice thing about the Stemplot is that it maintains, we can see the distribution of the data and we can recover the individual pieces of data. So the leaves are usually the last digit of a number, even if it's a decimal, and the stem is usually the first few digits of a number. So we're going to create 2 columns, left for stem, one on the right for leaf, so stem and leaf. List each of the stems that occur in the data set in numerical order. So if there's 0, 1, 2, 3, and 4, we do that in order. And we list each leaf next to its stem. So 0, 0, 5, 0, 1, 7, 7, and so on and so on and so on. So what we've got here is we've got 0, 0, 0, 0, 0, 5, 1, 0, 1, 1, 1, 7, 1, 7, and so on. So that's what these stem and leaves essentially mean. Okay. Now I realize that we don't normally write 0, 0 as a number, but that could be something meaning something else. If the leaves are put in numerical order, right? So let's go back to those percentiles that we were talking about earlier. And you can think about what's the minimum score. Well, the minimum score is it the 53, I think? And the highest score was 100, because that's the highest percentile. Well, technically the 99th percentile, but we'll let that slide for now. So these are going to be our stems. Those are our stems. And then with a 3 and a 9, that's the 53 right there. So that means there must have been a 59. There it is there. So we can do the same thing we did before, and we can cross those off. 61 and 63. Where's my 63? Where did you go? There you are. 71, 72, and so on and so on. So basically we just we're drawing the stem and leaf plot to sort of condense this information down for ourselves. And it also makes sure that we don't count any of these things twice. There's a 72, there's a 73, and where's the other 73? There it is. So anyway, that's on down the line. So when we're all done, that's what the stem plot will look like. Okay. This is the stem and these are the leaves. So if someone handed you a stem plot and said, okay, well, what does the data look like? You could reverse engineer it and say, well, there must be 53 in there, and it must be 59, there must be a 61, there must be a 63, 71, 72, 73, 73. So, and you're actually writing this in order, which is kind of nice because then it enables you to find things like the median, right? And things like that. So another nifty tool is that you can use your calculator to type all these in as well. So that's the stem plot there. If the data creates too long of an overall leaf, the stem can be broken up into 2s or 5s depending on the amount of data. So notice here we have 2 sets of 5s, 2 sets of 6s. Because some of the 7s, there was a lot of them, so we sort of broke it up a little bit more. That's an alternate way of doing it. Okay, a time plot can be placed on the horizontal axis, and the variable being measured is on the y-axis. Connect the data points with lines to help emphasize any change over time. And we look for overall trends and cycles in the patterns. Dow Jones Industrial Average will fluctuate throughout the day, but what is the overall trend throughout the day, week, month, or quarter? Okay. So we can do an ordered stem plot with the following data. So this is sort of an example for you. Again, download the PowerPoint, see if you can do that. Use 1 stem for each class, use 2 stems for each class. So you're going to do 2 different ones. So let's see, what is the smallest value that we have here? Is it 17? So you would have to put 1, 2, what's the highest value? 35? Yeah, so you would need a 1 and a 2 and a 3. So let's see, 17 we said was the lowest one. Okay, so 7, 8, 8, 9. Did I miss any? Okay, so 20 would be a 2 and a 0. Oop, I missed an 18, didn't I? Okay. And we have 21, 22, 23, 24, 24, 25, 26, 26, 5, 6, 6, 7, 7, 9. So I sort of ran out of space here. And then 31, 35. Okay. Anyway, so it's basically, oh, I missed 32 also. 32. Anyway, so what does the overall pattern of the data suggest? You can think about that and see if you can answer that question on your own. All right, so another health example here for you. Monoamine oxidase, MAO, plays a role in behavior. We took a blood sample from 42 patients and measured the MAO activity in the platelets. The results are given in the table. The dot plot is also displayed in the figure here, which will be on the next few slides. It's much easier to get a feeling for the data by looking at the graph than it is to read through the data in the table. So you'll see that. The use of graphical displays is a very important part of data analysis. Question, could we create a stem plot or a histogram for this data? So here's the data here. You've got diagnosis 1, diagnosis 2, and 3, which each has its own definition. And then we've got, within each diagnosis, we've got MAO activity for these patients. So here we've got 18, here we've got 16, here we've got 8. So there's what's called a dot plot, right? So again, this is a categorical example. So the diagnosis 1, 2, and 3, and the dot corresponds to the MAO activity for that patient. So these are decimal values rounded to the nearest tenth. So the dots here, the height of the dot is whatever decimal corresponds to that on the number line. So you can sort of, again, get a sense for diagnosis 1, diagnosis 2, diagnosis 3, and enables you to sort of get a quick visual look at how they compare to one another. That concludes our video for today, and have a good day.